Okay, reviewing today for our upcoming unit test, Unit 3 and sections 4.1 and 4.2. You should review the previous quiz. So from Unit 3, everything on the unit test will look a lot like what you saw on the quiz. Things that people consistently underperformed on. One was algebraically proving that functions are even or odd. So let's take a look at one. We want to prove this function is even or odd. So you have a gift given to you in a chart that tells you this is what you have to do. You have to show f of x is minus absolute value of x plus 4. Then you have to find f of negative x. That means you look at f of x. So we know that f of x is minus absolute value of x plus 4. I'm going to find f of negative x. So I'm just going to substitute a negative x everywhere that I see an x. So change that x to a negative x. So that's all I did was substitute negative x in for x. Okay. Now you have to look at it with absolute value. When you look at this absolute value, what you have is you've got f of negative x equals negative. That's the absolute value of negative 1 times x inside the absolute value sign. Okay. And then what is the absolute value of negative 1? That is 1. So what you end up with, and we bleed over into the other column, you end up with f of negative x is minus absolute value of x plus 1. Okay. So f of x is negative absolute value of x plus, and sorry, I don't know where I got a 1 from. That is a 4. So negative absolute value of x plus 4. Now what I see is that f of negative x equals f of x. So that means this is an even function. Why is it even? It's even because f of x equals f of negative x. And now I'm asking you to support, is it odd, yes or no? So let's look and see what would it mean if the function were odd. You've got f of x equal negative absolute value of x plus 4. To find negative f of x, that's just a negative on both sides of this equation. So negative f of x is equal to the negative of negative absolute value of x, and then minus 4. So minus f of x is equal to the absolute value of x minus 4. So we now know that this is not an odd function. The reason I know it's not odd is f of negative x does not equal negative f of x. Okay, so I was looking at these two comparisons. Negative f of x is absolute value of x minus 4. F of negative x is negative absolute value of x plus 4. They are not equal. It is not an odd function. That is the reason. A couple more examples. Prove even, odd, or neither. So same basic process. F of x, in this case, is negative 2x squared plus 3. F of negative x is going to be equal to negative 2 negative x squared plus 3. Negative x times negative x, that's the same as x squared. So f of negative x is equal to negative 2 x squared plus 3. So that means this is an even function. So it is an even function. It is even because f of x equals f of negative x. Looking why it's not an odd function, if f of x equal negative 2x squared plus 3, then negative f of x is just the opposite of this. That's 2x squared minus 3. And what I see is this and this, those two things are not equal. So this is not odd because f of negative x does not equal negative f of x. Let's look at one more example here. F of x is negative x cubed plus x. So f of x is negative x cubed plus x. F of negative x is going to be negative x cubed plus negative x. Okay? So when you look at negative x cubed, let's just look at that over here. Negative x cubed. That's negative x times negative x times negative x. The negative and the negative, negative, I'm going to have a negative. This is just negative x cubed. Okay? And so if you look at this, so I'm going to have f of negative x is going to be equal to, this is going to turn out to be x cubed minus x. Okay? And I see that these first two things are not equal to each other. This is not an even function because f of x does not equal to f of negative x. Now let's find what negative f of x is. So if f of x is equal to negative x cubed plus x, to find negative f of x, I put a negative in front of both sides. So that turns into negative f of x is equal to x cubed minus x. And I see that this and this are identical. So this is an odd function because f of negative x equals negative f of x. Okay, so that's looking at the first three problems, algebraically proving that functions are even or odd. We'll take a break and come back. Well, we'll do one more. There is one more. Let's finish this up. So f of x is x squared plus x. So f of x equal x squared plus x. F of negative x is going to be equal to negative x squared plus negative x. So negative x squared, that's negative x times negative x, that's the same as x squared. So f of x, it's going to be f of negative x is x squared minus x. So I see that the first two do not match. This is not an even function because f of x does not equal f of negative x. Now let's go on. Let's find out what negative f of x is. So if f of x is equal to x squared plus x, to find negative f of x, that's just a negative in front of both sides of that equation. So negative f of x is equal to negative x squared minus x. Now you see that the second two columns do not match. This is not an odd function because f of negative x does not equal negative f of x. So this is neither even nor odd. Okay, let's take a break and we'll come back and finish this up.